This is 1-5, solving equations with variables on each side. I like these steps for solving equations. I kind of want to add one in between step 1 and step 2. It's to make sure that the variables are on the same side. Really, that's part of step 2, but I just want to make it clear that we have to move the variables to the same side. So first it says simplify the expressions on each side, use the distributive property if needed. I don't need that for example 1a, but like I said, that step in between 1 and 2 is what I would say is get the variables to the same side. I can't highlight my variable right now because I have two of them. I've got 5k on one side and 3k on the other. But we do use addition or subtraction property of equality to move that. So what I'm going to do is I like to move everything to the left. So I'm going to subtract 3k from both sides. Notice I only put it underneath the k's because I'm keeping my like terms together. The 3k's cancel, and so on the right, and so I end up with 2. 5 minus 3k is 2k equals negative 6. Now I can highlight my variable. And I know I need to get the positive 2 away from the 2k, so if I subtract 2 from both sides, that's going to leave me with 0, which is what I want. And on the left, those are both negatives. So if you're at negative 6 on the number line, you go negative 2 more, you end up at negative 8. Divide both sides by 2. And k equals, when we multiply or divide with negatives, one negative will give us a negative answer. So k is equal to negative 4. And we could still check our work, plug that negative 4 into the k spots in the original equation, and both sides will equal each other. In example 1b, I can't do anything from step 1 again, simplify the expression on each side, but I can get the variables to the same side. That's step 1.5 I said, kind of in between 1 and 2, which is really step 2, is to get the variables to the same side. I want you to notice something though. This x over 2, let me point to it for you. The x over 2 right here actually is a 1x. There'd be a number 1 in front of it, and so this is really a 1 over 2x. So I'm going to rewrite this as 1/2 x. I think that might make things easier here. So now I'm going to get my variables to the same side. I'm going to subtract 1/4 x. Since it's positive 1/4 x here, I'm going to do the opposite, negative 1/4 x to both sides so that that cancels. And I end up with 1/2 minus 1/4 x, which is 1/4 x plus 1 equals negative 6. I can now highlight my variable. And I'm going to be getting rid of that plus 1 on both sides. So I'm going to subtract 1. I mean, it's the plus 1, but I'm going to subtract 1 on both sides. And I end up with 1/4 x equals negative 7. And this is where we have an option if we want to multiply by the reciprocal 4, or just multiply by the denominator, which happens to be 4. So we end up with 1x, which is just x equals negative 7 times 4. Since there's one negative when we're multiplying, it's going to be negative, and 7 times 4 is 28. Again, you can plug in that negative 28 into the x spot. I'll show that one. Okay, and so negative 28 over 2 is negative 14 plus 1 equals 1/4 of negative 28 is negative 7 minus 6. And negative 4 plus 1 right here is going to get us negative 13, and negative 7 minus 6 is negative 13. So this is definitely correct. Okay, in example 2, if I go back to my steps of solving an equation, step 1 says to simplify or use the distributive property if needed. So I need the distributive property here, and I also will need it here. So let's start with that. 6 times 5m is 30m. Minus 6 times 3 is 18 equals 1/3 of 24m would be 8m plus 1/3 of 12 is 4. Now I can get the variables to the same side. I'm going to move the 8m, so I'm subtracting 8m from both sides. I get 22m minus 18 is equal to 4. Add 18 to both sides. 22m equals 4 plus 18 is 22. Now I can get m by itself by Division property of equality, divide both sides by 22, and m equals 1. We can plug that in and check. If you plug the 1 into right here, you get 5 times 1 is 5, minus 3 is 2, times 6 is 12 on the left side. And on the right, 24 times 1 is 24, plus 12 is 36, and a third of 36 is 12. So 12 equals 12. That's correct. Okay, in example 2b, I'm going to need distributive property again. So when I do that, I get 7n minus 7 equals negative 2 times 3 is negative 6. Negative 2 times n is negative 2n. Get the n's to the same side. And I end up with 9n minus 7 equals negative 6. I can highlight my variable. I didn't do that in the last one. I like to try to keep it consistent here. So I know that I have to get rid of the plus 7. I'm sorry, I have to get rid of the minus 7, so I'm adding 7 to both sides. Thinking ahead. 9n equals negative 6 plus 7 is positive 1. Divide both sides by 9, and n is equal to 1/9. You can still check your work on this one. I did so on the right-hand side, and I got negative 56 over 9 equals negative 56 over 9. So it's correct. Okay, now there are times when we're solving these equations, and when I bring the variables to the same side, the variable actually disappears. So when that happens, if your remaining statement is false, you're going to get no solution. If the remaining statement is true, you're going to get all real numbers. So let's look at one so that we can see what we're talking about here. Example 3a. Okay, step 1 of solving equations, though, is to simplify on each side or distribute. So we have 5x plus 5 equals 3 times 5x is 15x, 3 times negative 4 is negative 12, and then we put back that minus 10x that was at the end. I can even combine like terms on this, on the right side of the equal sign. So 15 minus 10 is 5x minus 12. Now I'm going to get the variables to the same side. So I subtract 5x from the right and subtract 5x on the left. But what happens is the variable, it cancels on both sides. And I end up with 5 equals negative 12. Since this is false, my answer is no solution. You have to show that. You can write out no solution, or you can use that symbol. Okay, so for the next one, example 3b, I'm going to distribute, so I get 6b minus 3 minus 7 equals 6b minus 10. I'm going to combine like terms. I can still simplify. So 6b, and then the negative 3 and negative 7 become negative 10 equals 6b minus 10. I already know that this is going to be all real numbers because these are totally equal to each other. But if you didn't notice that, you can then do minus 6b from both sides. The variable goes away, and I end up with negative 10 equals negative 10. Since this is true, my answer will be all real numbers. So you can write that out, or there's a symbol for real numbers, an R with the extra line. Okay, Miss Griffin pays $10 each month for movies delivered by mail. She can also rent movies in the store for $1.50 per movie. Let me highlight some information here. So I've got, it's $10 each month. She can also rent movies for $1.50 per movie. Write and solve an equation to find the total amount Miss Griffin spends this month if she rents 3 movies from the store. Okay, so if it's $1.50 per movie, and she's going to be renting 3 movies, I can tell that eventually I'm going to need my 3 dropped into that movie spot. But I'm thinking in terms of writing an equation now. So we're trying to find the total amount Miss Griffin spends this month. So I'm going to call that my y equals, Miss Griffin pays $10 each month. Well, we're talking about for 1 month, so that would be $10 that she pays plus $1.50 per movie. 1.5x or $1.50x. Okay, and from there, like I said, if she's going to be renting 3 movies, I know that I'm going to need that 3 to go into my x spot because it was per movie. So now I have y equals 10 plus 1.5 times 3. Y equals 10 plus 1.5 times 3 is 4.5. So my final answer is y equals 14.5, and that would be in terms of money because it says how much did Miss Griffin spend. Well, that would be $14.50 is what she spent.